Good morning to everyone. My name is Daniel Sazbon. I am the chairman for SNIA Europe. I'm very glad to have Alex McDonald with me, the vice chair of SNIA Europe. And together we are going to describe and introduce Swordfish to you, the scalable storage management. So as we start, a few housekeeping disclaimers. First of all, this information is given to you on an as-is basis. There is no guarantee that this technology will take form or shape in the industry in the future. This is development work and research work that is being brought to you in order to optimize and improve storage management in all of the environments that we all have. Second point is that you can put your screen in full screen mode, so as you can see better the descriptions and what we're going to comment. And the third thing I'd like to mention is that at any time you can provide us feedback, ask questions, and of course in the end we'd like to have your overall feedback of this audience, of this session. With no further delay, I'd like to introduce Alex McDonald. Alex, please go ahead.
Thank you, Daniel. I'm just going to take us through the slides that you didn't move through. That's fine, though. There's you and I, looking very handsome, very debonair. And that's the disclaimer. That's SNIA, but we've covered that before in terms of this audience.
Yes, we have covered that before, yes.
So, some of you may have been on the previous presentation that I tried to give where there was absolutely no sound. This time we've got sound and slides, hurrah! And today I'm going to be taking you through Swordfish. Swordfish is entertainingly named. Why it's called Swordfish is fairly obvious. The DMTF, the Distributed Management Technology Forum, described their process of managing servers as Redfish. Why did they call it Redfish? Not a clue. I really don't know. And I've never bothered to ask, actually. So basically, Swordfish is an extension of the DMTF Redfish specification. And we've developed this to manage and extend Redfish, which manages servers primarily. And we've extended it out to manage storage so that we've got a storage interface as part of Redfish. And I'll explain why that's important in a second. It's very much to do with the overall manageability of the data center and the resources in the data center. So this presentation is all about how Swordfish extends Redfish. And we're going to assume no knowledge of either, by the way. We're going to go through this from I'm going to assume that you're absolutely ignorant, but infinitely intelligent, and we'll go forward on that basis. So, as Daniel said, this is a snapshot of the progress with the work within SNIA and can change without notice. It's highly unlikely to change that much, though, because the specification is beginning to really solidify, and we're up to version 1 of the specification that's been ratified. So the changes are going to be fairly minor in nature at the moment for version 1. But there's an entire website devoted to this, and I would recommend that you take a look at it. This covers not just this material here, but also lots of other material to do with storage management. And that's snia.org/swordfish, and that's a central location for all this storage management information that SNIA develop and present. So, customers and vendors, who are they? Well, customers are people who consume storage, and vendors are people who provide it. That's fairly obvious. But there's been some discussion over the years about simplified storage management APIs. We have a storage management API already called SMI, the storage management interface, but it is primarily C API based and is fairly difficult to write to and requires quite a lot of programming skills, particularly to consume the information from SMI. What we've done here is made it simpler to implement and consume by using RESTful based APIs, and I'll discuss what they look like, and using JSON, which is a text format that's human readable as well as machine readable. So we're trying to improve the access efficiency without doing transactions. So if you think of a stateful environment whereby you're perhaps opening up an interface to go and talk through an API and then having to keep state on both sides, that's relatively complex. That's transactional in nature. And we've tried to reduce the amount of transactions that are going on so that we can have a stateless implementation. Nobody knows to keep state at all. The storage object just responds to requests as and when they appear. It also, because it's based on RESTful APIs, JSON, and HTTP, it provides access via a standard browser. And that's actually a very positive and powerful debugging tool. Plus, it makes it easy to design GUIs and implementations that consume this information. The other thing that it's intended to do is be expandable. So it includes not only converged, but hyper-converged, hyperscale, and a variety of interfaces, and I'll cover those as well, block, file, object, etc., security aspects. We're trying to encompass as much as we can of the management technologies that we need to manage in a modern storage environment. And we'll also provide compatibility with standard DevOps environments. They are primarily not based on C APIs, but based on much higher level languages and much more flexible RESTful APIs. So those are the drivers. So the Swordfish approach was really quite simple. We already had a schema. We already had a way of managing through SMI. The interface that SMI gave us was very powerful and a really good model for managing storage. What we've done in the process is moved to a class of service-based provisioning and monitoring, and I'll show you examples of that a bit later. We cover all the traditional pieces of storage like block and file, and some of the newer technologies like object as well. And we're trying to extend this traditional storage domain to include these converged environments. A converged environment is one where you've got both CPU, storage, and networking all in the same entity, if you like, and it can be managed as a single object. So we're extending it out to that, you're also including things like SAN and NAS, obviously, but also hyper-converged. And when we looked at it, we decided to leverage and extend DMTF's Redfish specification. Now, that's a server management specification that is RESTful APIs based on JSON, HTTP, and is a very powerful way of managing servers. And that has actually been a lot easier because it means that, first of all, we're not designing a completely new interface for a completely new set of technologies. We're redeploying an existing set of specifications by simply extending them. So it's an extension of the Redfish API. And if you want to see the Redfish API, if you go over to the DMTF's website, you'll find a fairly extensive, obviously, a specification of Redfish and what it does. So who's doing this? Well, if you look at the list of people who are doing Redfish, and the list of people who are doing Swordfish, and the list of people doing both, it's about all the great and good in the storage industry and in the server industry that are doing this Redfish and Swordfish work. So there's a great deal of industry support for this, and we're beginning to see implementations based on Swordfish. We're beginning to have work be done. I don't know of any commercially available Swordfish implementations yet, but I'm sure they're becoming very shortly. I know of a number of people and companies that are working on Swordfish implementations. So it's very positive, and it's going to be very popular, and partly because as well it is replacing to a large degree the kind of interface that we had with SMI, and that is actually going to provide people with an easy route to supporting Swordfish because the schema is very much the same. And a Swordfish implementation over the top of your existing SMI shouldn't be too much bother. Said he, not having done one, but I'm assured that that's the case. So Swordfish, we started out in 2015, which was not that long ago, and we had our first spec out in 2016. This last quarter, 2018, so this presentation is pretty fresh. We updated the Swordfish mockups. There's actually a website out there called swordfishmockups.com, and I'll run you through some of that so you can actually see what Swordfish looks like. And we've also just come out with version 1.0.7 of the spec, which is in draft review at the moment, and that came out in November 2018. And that added a variety of additional features that we were looking for, things like spec, capacity management, how rebuilds are done, describing volumes. There's basic Swordfish support work in progress being done to develop profiles, and profiles are simple use cases that can be used to build on and demonstrate how you might use Swordfish in real life implementations. So there's a number of focus areas that we've got: validating the spec, proof of concept implementations, documentation, open source tools, I'll cover those as well, and implementation support. There's actually a Plugfest. You can see the address there at the bottom. That Plugfest allows us to have implementations of both the clients and the server software interoperating to make sure that the spec is not ambiguous in any way and is actually executable. So there's been a huge amount of work being done since December 2015, which is only 3 years ago. Goodness, it's already December 2018, so it'll be 2019 shortly. Christmas is nearly upon us. So what functionality was included in the version 1 spec? So basically, the three things that we need that are essential for addressing the current storage regime. First of all, block storage. So the ability to do provisioning, the ability to do volume mapping and masking, so we can actually see volumes and mask them so we can't see them. So, you know, the usual ability to, if you like, securely enforce boundaries in our environment. Local and remote replication, how do we describe those in a block environment? So whereby we can remotely, for instance, replicate and actually have the description of that and some management process for being able to do it. Capacity and health metrics and performance, and I'll show you those as we're going through. Then obviously we've got file system storage, which is the other part of the equation. That adds file systems and file shares and leverages all the other concepts that are already in place with the block side, you know, things like the class of service, and as again, I said, I'll cover those shortly. And then how to get connected to this stuff. How do you connect to a fabric to get access to the storage? How do you connect to get access to the storage being provided to the host? And effectively abstracting the endpoints so that the consumer of the storage doesn't really need to know very much about the storage at all. In particular, doesn't need to understand any vendor vagaries that there might be about accessing this storage, but simply goes out there and can use Swordfish to gather enough information to make that connection to the storage. So if you're thinking in terms, by the way, of the data flow here, this data is, if you like, the management layer, and the endpoint abstraction is the data layer, the data transport layer. And then we've got additional contents. We've got object drive storage coming along as well. And there's actually an object drive technical work group within SNIA that are defining what object drives look like. And when they've settled down on a preferred interface, then we'll add that too. That'll be a relatively straightforward, as you'll see. So what is Redfish? Let's have a quick look at Redfish. Redfish is basically a hierarchical structure that has a root, and then from the root, a variety of information that flows out from it. Now, this is where you probably find it useful having a screen in full view, because otherwise you're going to miss out on the details. It's actually quite a small letterbox you'll probably be looking through otherwise. So what we have here is on the left-hand side, if you look on the left-hand side, there's something called the root resource, and that's the Redfish root that provides information about a variety of things: sessions, accounts, schemas, events. So there's a variety of information being collected at the root level. And then to the right of that, there are various managers that provide management of servers and descriptions of the chassis, which are the physical items, and then the systems, a logical view, that sits over the top of that and points out to the systems that are managed in this particular chassis. So you can see things like, for instance, processors, disks, network interface cards, all being described as part of that hierarchical structure. Plus there are dotted lines. Oh, I beg your pardon, before we do that, some of these lines are one to many. So you see some of them are marked 1 to n. So there's one systems object that contains a number of systems. So there's a relationship of 1 to n for that particular object. And then there are a number of dotted lines between each of the individual items that provide a non-hierarchical view, a relationship, if you like, between various elements within that overall structure that Redfish imposes. So what does a hosted storage configuration look like? What if we were to add storage to this description of the server environment? So what we effectively have is the Redfish piece, which describes our servers. And what we're going to do is build on top of that a piece that's actually the storage system. So we've got an object called storage systems, and within it is a number of other objects with the individual storage systems. And they've got, for instance, various bits of information to do with model, status, the controllers it contains, the disks it contains, fiber channel interfaces. And then on top of that, again, we can build another object, which are the services that are provided. And the service object has within it a number of objects that are related to volumes, to files, to replicas, to a variety of services that those underlying storage systems can implement. And you'll see the dotted lines there that describe the relationship between the service, which is a logical view, and the physical storage systems underneath it. So here's a way of describing and mapping a storage environment in the Redfish vernacular. And what Swordfish is doing is extending Redfish, as you can see. It's not actually replacing any part of it. And it's building this hierarchical information structure with cross-link pointers that allow us to move easily down through these structures to be able to find various bits of information, and also to be able to have those systems report back and log things like events and various other asynchronous activities that take place in a storage environment. So that's how we do a hosted service configuration. What if it was integrated, for instance, in a hyper-converged environment? Well, in that case, we'd have the same structure, except that on top of it, we have a storage object that comes out of the systems part, because the storage is obviously part of a system, a server system. And then on top of that, we build a logical view over the top of it, which is the storage services, which is very much like the previous example on a hosted environment. So in the integrated environment, the storage is part of the server environment, but we build the storage services over the top of that, much in the same way as we did for the hosted environment. So that's a fairly high-level view of the structures that go into making up the Redfish and Swordfish environment. So what are the elements? What are we maintaining in these elements when we're describing these systems? So what we have is, for instance, a class of service. And you can think of a class of service as being like, for instance, a bronze or a silver or a gold or platinum, or however you might describe it in terms of precious metals, or perhaps you've got a 1, 2, 3 or an ABC to define some kind of class of service. What is it you expect from this system in terms of its performance, in terms of its location, in terms of its reliability? So there's a number of things we can do to describe a class of service. Then underneath that, the storage service, which is actually the provisioning of that class of service. And underneath that, storage pools that provide us with the storage. So these are hierarchical descriptions of how to go about describing a service. Then below that, the individual pieces, the volumes, the storage groups, the file systems, and the file shares that we can present up through these storage pools and then onto the class of service. And I'll show you how you could make a request of the system to get some space, for instance, and that hierarchy being done in action. So those are the primary elements that we're keeping. A lot of information about each of the logical and physical components and how they interrelate together. So there's actually a set of mock-ups, and I'm going to go through these mock-ups in a second. We'll not do it interactively online. It's a little difficult in this interface. But we'll go through these mock-ups, and there's actually a website out there called swordfishmockups.com, and that provides you with a representative set of interfaces that you can move through and actually work on it. You can see the kind of information you can get back from a static snapshot in time of a storage system. And remember, these are just representational. They're not actually normative. These aren't part of the spec, but they are actually good examples of the kind of information that you should be able to see. So if we went to that website and looked at these mock-ups, we would actually see something that looked like this. So this is the output from a query. So what the mock-ups provide you with is a data model to explore. I've explained the overall structure of the data model, and obviously the spec describes it in a great more detail. And then the ability to navigate through that data model. And the mock-up itself shows two examples of a block storage system. The first one is a simple, which is a single small external array. And then the second one is slightly more complex, is all the elements of the block storage model with remote replication. So it's a much more complex model, and you probably best start with the simple model, understand that, then move on to the more complex storage model. And also an example of a file server with multiple file shares, which is the other major consumption model that we've identified so far with Swordfish. On the right-hand side, you'll see JSON. Now, again, that is quite difficult to see, and I'm going to explain what's in there very briefly. So this JSON is effectively the result of doing a request to the storage, and I'm getting back information about what systems it contains, the storage services it has, the managers, the tasks. There's a variety of information that I'm getting back from that root level Redfish interface that contains my storage systems information as well. So that information is the high level that I get back when I ask for the root resource. And from the root resource, I can then navigate out to other parts of the system. So navigating from there, if I select the storage services link to see the collection of storage services, what storage services do I have, then I'll see that I've actually got a simple, which is the one I talked about, which is the simple array. I've actually got the complex, which is actually marked as 1 for some reason. I'm not quite sure that's why it's not complex, but it's marked as 1. And underneath that, again, underneath that storage services link, I've got file service as well. So I've got 3 different collections that I can actually go and use and explore with an API, representing the storage I have, or the mocked up storage I have in this system. So on the right-hand side, you can see I got the request back, and there were these 3 links I've got out to the simple, to the complex, and to the file service example. And then when I drill down further and look in the class of services, if I click on the class of services, then I'll be able to see volume information, pool information, group information. So that the information is being aggregated together and presented to me as collections of objects in these various subclasses. And then obviously pointers to related resources. These are the non-hierarchical bits. These are the bits that point off to other related pieces. So those related resources might actually be the physical storage entities that provide these resources at a logical view level. So that's the storage service for block. If you look at the file, it's exactly the same, except that it describes file systems. It's got pools, it's got groups, it's got endpoints that describe how to get access to it, and pointers to related resources, including the block service on which it's based. So again, exactly the same information, just a superset of the block information that I've got described within this system. So let's try and do something that an application might do. So let's say that we're wanting to build an interface that goes off and allocates some storage. So the first thing is I want to ask of the storage system is, do I have the capacity to do X? I need to, I want to allocate a terabyte of storage, for instance, on a block device. So I can actually go and drill down through, look at the storage pool I'm interested in, look down into special pool and check its remaining capacity. And if you look carefully, and you'll have to use a microscope, I fear, because of the granularity of this, you will actually see here that there's actually descriptions of the amount of consumed bytes, the number of allocated bytes, the number of guaranteed bytes, the number of provisioned bytes. So there's a whole description of the underlying storage pool that this resource will come from, this file system will come from. And that kind of information is obviously static, so you're not going to see that dynamically change in the model. But obviously, if we were in a real environment, that would be dynamically changing. I'd be able to go out there and query, how much space I have left in the chart in about 5 minutes. I'll have an application go out there and make sure that before it allocated a terabyte of file system, that there was a terabyte available in the correct storage pool and that would be correctly replicated, and et cetera, et cetera, et cetera, and what the endpoint was to get access to it. So there's a variety, there's enough information in a Swordfish environment to actually manage that entire structure of going out and allocating storage, of deleting storage, of provisioning storage, of managing the storage from a capacity and performance perspective. So a huge amount of information that this simple structure that we built over the top of Redfish is capable of giving us. So that's an example of just simply drilling down. And remember, that's in the swordfishmockups.com website. You'll be able to go and use that. So how do clients determine the Swordfish implementations they can support? Well, that's really quite simple. There's a set of profiles that we can define that allow you to define the kind of functionality you expect to see from your Swordfish requests or implementation. And basically, there are going to be a couple. The basic one is service configuration for both integrated, that's stuff where you've actually got disks on the server, and hosted. In other words, we get an external SAN or NAS. So that's a basic Swordfish support. And then there'll be add-on functionality that you can query to see whether it exists or not from the particular storage device, to do with things like local replication, remote replication, and so on, advanced functionality. And then we're going to be also adding in things like, for instance, Energy Star requirements, so that if you've got a requirement to manage the power consumption and the ways of monitoring that, and the storage system can provide you with it, you'll be able to express that up through Swordfish. So there'll be certification of conformance requirements as well. So there'll be a basic set of profiles, and then these add-on profiles, and a Swordfish client, that's the requester of the storage, will be able to interrogate the storage system through Redfish route down through the storage elements to the Swordfish elements to work out what exact profiles that this particular implementation supports.
Alex, let me allow you to pause for a second and remind the audience that if you have any questions, you can ask them online right now on the right-hand side of your screen. I think this is a very good description of Swordfish and its capabilities. Perhaps you can start summarizing, Alex, for the audience.
So I think the important thing about Swordfish is to go back to the reason that we started it in the first place. We already have management interfaces. I mean, no storage system comes without them. But there are two problems with the current set of management interfaces. One, many of them, not all, but many of them are vendor specific. They're not particularly open. And two, those that are open depend on things like SNIA, which is a standard it's more a set of APIs that you can call from C or C-like programs to be able to get access to the underlying information. Now, the structure within SNIA was good, the schema was good, so we've redeployed that in Swordfish. But what we've done is we've eliminated two of the problems that we're currently having. One, this is vendor independent. This is not specific to any given vendor. If a vendor supports Swordfish, they support a number of the profiles, at least the basic profile, plus any additional profiles that they may declare they want to support. That's the first thing. So it's not vendor specific. And secondly, it's much easier to program and consume than the SNIA interface was. And that, I think, is a real plus point. It makes it, if you can actually query this thing through a browser, you can imagine how much simpler it is to actually write an application. And I'll show, actually, in a few minutes, we actually have some sample applications that people can use as models for this. So in 2018, 1.06 was released in 2018. We've got this 107 in review in November this year. That's currently being reviewed. A lot of future functionality coming along as well. We're trying to get object storage in there. We're trying to make sure that we remain in alignment with a number of other external organizations like the, the DMTF and NVM Express people and SNIA itself, in terms of making sure that this Swordfish environment is representative of other work being done in other groups within the industry. And one of them that's dear to my heart is security. That's specifically, we're going to look at security as an up-and-coming thing, because currently the security is relatively basic, and we want to beef that up considerably and make sure that this is a secure environment in which people are operating. The other thing is that there's a number of open source tools and infrastructure development going on, and this is what I was talking about, the interfaces. If you go out to GitHub, there's a SNIA a subdirectory in GitHub, and that points to all our current open source work that SNIA do. And there are a few there that are worth mentioning on the Swordfish side. First of all, there's a Swordfish emulator extension, so you can actually build extensions to the emulator if you want to test out a client. There's a web client itself where you can discover and display Swordfish services, and you can actually add and edit new services while you're sitting there playing with the web browser-based client interface. There's Datadog, which is a dashboard integration piece that demonstrates how you might integrate with a dashboard, and one in particular is Power BI. There's a set of Power BI data center. Power BI is a data center monitoring system, and there are a number of Power BI interfaces there provided in this Swordfish set of implementations. So these implementations are designed to actually show the integration concept. I should perhaps explain, by the way, Power BI. BI stands for Business Intelligence. So basically, what it is, it's a high-level tool for displaying information from a data center. So there are a number of tools that we've developed, and in fact, there's a link out there that will take you to some demonstrations of these tools as well. So how do you participate? Well, shaping the standard is always relatively easy because we're always looking for input from people. And that includes, by the way, not just vendors, but also consumers and end customers, because this is important stuff, and we need to understand what the industry wants from us. And you can shape this. You can find the latest technical content out, as I said, on SNIA.org Swordfish. There's also the public review of the existing standard that you can get involved in. That's under public review #Swordfish. You could join the management twig. You could actually shape the standard itself. So there's actually a storage management twig, technical work group that you could join. And there's also a feedback portal. You can actually feedback what you think of this and what direction you'd like it to take through the portal. So there's actually a feedback for work in progress. So that's, in summary, the kind of things that we're doing with Swordfish. It's a very exciting time. There are a number of commercial organizations looking to implement this. There are, as far as I'm aware, no commercially available Swordfish implementations yet. It's too early in the day. I mean, we haven't had the spec out that long. And the development cycle for these things tends to be, as a friend of mine describes it, in Olympic years. In other words, it takes about 4 years for a very good idea to become commercially available. But I think that what we're doing with Swordfish is incredibly positive. It's much easier to consume than SMI. It's much easier then to take that information and to feed it into various other different tools. And our open source implementations of some of these as demonstrations shows that. And the spec is really easy to understand because it's not based on an API. It's based on RESTful techniques. It's based on JSON, and it's based on HTTP. The ability to actually see this stuff as a human being, apart from being through a debugger, is a really positive aspect to the whole thing. And I think Swordfish is going to seriously take off quite rapidly over the next few years, particularly since Redfish has become so popular. There's lots of Redfish implementations out there, and Swordfish is just a natural extension to it. So there you have it. Thank you, Daniel.
Very good, Alex. Thank you very, very much. It has been very contentful, and I think this is a journey into how storage management is going to enable new applications, business intelligence, whether it's in cloud, privates, publics, or a hybrid. So this is extremely interesting. Let me remind you that also SNIA Europe is organizing and running an event, SDC EMEA, which stands for Storage Developer Conference. This will be the second edition. The first one took place in January this year, and the second and next edition will be in January 2019 in Tel Aviv, and Swordfish and Redfish will be a basis for many of the topics being discussed in the conference. If you'd like to join or to participate, you have the web link there, how to do that. This will be very well attended, I'm sure, and this will be an excellent conference overall. I would also like to remind you that you can ask questions and provide feedback. By the way, we do have questions, Alex, from the audience. One of the questions is, do we have Swordfish Conformance Test Suite?
The answer to that is not yet. In that conformance testing is actually dependent on having a stable spec, because you're obviously testing to a specification. So the spec's relatively new. We will have a conformance test suite. We have plugfests where interoperability is the name of the game. And that's probably the area we're going to focus on most at the moment. There will probably be a conformance test suite, but no, there isn't one currently.
All right. Thank you. And so let's wrap up by saying that this is a very important topic for the future in storage management. Please provide feedback on this session and whether you'd like to have other sessions in the future. And I'd like to thank you for your participation overall. And Alex, thank you very much as well.
Yes, thanks to our audience, and thank you, Daniel.
Thanks. Bye-bye.
Bye now.